Matt is with us tonight from Wisconsin. He is a Coldwater Fisheries research scientist with the Department of Natural Resources in Wisconsin. He's got over 20 years in fisheries research and fisheries science. He focuses mostly on inland trout species, and he's got a number of projects here that I just want to mention off a couple of them here. Long-term trout and stream habitat monitoring, research on gill lice infecting brook trout, protocol development for age estimation in brown trout and brook trout, and modeling changes in temperature and trout distribution in response to climate change. He's also done a lot of work contributing to trout and beaver management systems. So what we'll do is turn it over to Matt.
So I'm going to present today about a project I've been working on for a number of years now on beaver dams and trout habitat and trout fisheries in Wisconsin streams. Again, I work with the Wisconsin DNR and the Office of Applied Science and their fisheries research program based in the state capital of Madison, and I work around the entire state. So, as you heard in the introduction, beaver and trout have been kind of a contentious issue for many people for many years. In Wisconsin, for a long time, many of our trout biologists and trout managers and many of our trout anglers alike have long considered beaver and trout to be incompatible on our relatively low gradient streams in the state. And as a consequence, it's kind of been a general policy to remove beaver dams with the intention of benefiting trout and trout streams. This happens both by private landowners for various reasons on streams that flow through their lands. But the Department of Natural Resources also has a beaver control program as a core part of our trout management strategy, where we contract with Wildlife Services, a federal agency, to do the beaver trapping and beaver dam removal on a certain percentage of trout streams that are typically on state-owned lands or on lands in which the state owns an easement on the stream. And this is a picture of one of our Wildlife Services people, along with one of my technicians, removing a dam on Ash Creek in southwest Wisconsin. And we kind of timed our work with them to do this at a time when we can do a survey on this stream following the lowering of the water level. So these are the primary species of interest that we are concerned with in our inland trout streams. Brook trout on the left, the only native salmonid in the inland streams of Wisconsin. And on these are found throughout coldwater streams in the state. And then on the right, the brown trout, not native to Wisconsin or North America, but introduced over 150 years ago, and they've become naturalized. And we have many wild brown trout fisheries throughout the state, which are also very popular with anglers. And then on the bottom, a picture of the beaver. In Wisconsin, we do have a lot of beaver. It hasn't always been that way. We've had beaver and trout kind of coexisting in the state for many years. But over the last couple of centuries, they've kind of alternately been decimated and recovered. And we're kind of at a point now where both beaver and brook trout are doing relatively well, with the exception that brook trout were eliminated from many of our streams due to poor land use practices in the past century. And when we were able to improve our watershed practices and improve the streams, brown trout were then introduced, thinking the streams may not be good enough to support brook trout again. That was unfortunate, as those streams certainly could produce or support brook trout now, but we do have brown trout in them. So I'll start by just kind of reaching back a bit into the history of beaver and trout research and management in Wisconsin. There's not been a lot, but there's been a few key reports that have been put out, and I want to highlight three of those here. One of these was put out by Donald Patterson in 1951 on beaver and trout relationships, and another by George Knudsen in 1962 on relationship of beaver to forests, trout, and wildlife in northern Wisconsin. Both of these reports, they seem to heavily rely, as far as the effects of beaver on trout fisheries, they seem to heavily rely on reports from trout anglers. So it was trout anglers' experience with beaver dams on trout streams that kind of led to a lot of the observations that were in those reports. The last one was by Ed Avery. This came out in 2002. He was my predecessor in the DNR, one of our trout researchers. And he did a kind of more specific scientifically grounded study on a particular stream system up in northeastern Wisconsin. And that looked at fish community and habitat responses to removing beaver from trout stream over an 18-year period. So it wasn't a continuous study, but it was a stream system that was revisited a number of times over that 18-year period. And just to give you a sense of the scale of what he worked on that stream, I don't have the numbers right in front of me, but I think it was maybe a 25-kilometer system of the North Branch Pemmican River and a number of its tributaries. And over that, in the course of a couple of years, they removed close to 600 beaver dams. It was almost a beaver dam every 100 meters or so. So it was to the extent that this free-flowing stream had been converted essentially into a series of ponds. And so his project involved changing that back to a free-flowing system. So I kind of put together a list of some of the positive and negative effects of beaver on trout streams that I kind of gleaned from those three studies. And as you can see by looking at this slide, there's not many positives that were reported and quite a few negatives. On the positive side, new beaver dams have been seen to increase the size and number of brook trout for at least the first few years after the dams were created. And again, a lot of that observation was based on the result of trout anglers. So trout anglers kind of knew that when beaver kind of set up shop in a stream and built a dam and created a bigger pond or bigger pool on the stream, fishing tended to be pretty good for a few years, and anglers did well. But that did not persist, and typically when you got past 4 or 5 years, these streams started to deteriorate a bit, and the fishing deteriorated as well, and so anglers would move on. It was thought that it was probable that the beaver dams and the siltation affected the spawning areas, potentially interfering with trout spawning. Again, because of the low gradient of these streams, we have excessive siltation that, as these ponds would fill up, really decreased the carrying capacity for trout. And again, anglers noticed that. They stopped catching trout and moved on to other streams. Beaver dams were also perceived as restricting trout movement and warming stream temperatures, and that the conditions created by these beaver dams were kind of favorable to cool and warm water fishes, less so to the cold water fishes like brook trout. I'll share one more thing from those reports. This was from George Nitson's report in 1962, and it's one of the diagrams he put together that I think really displays well what we see on these stream systems in Wisconsin when beaver build dams. So if you start at the diagram on the upper left, that shows a stream meandering through a floodplain. The floodplain are typically wooded, maybe trees or shrubs. When a beaver comes in and builds a dam, they don't only build the dam just across the stream channel, but it reaches up and across the floodplain. And given that these streams are relatively low gradient, they do reach out across quite a distance across these floodplains and create these very large pools, as you see by the shaded area in the figure on the bottom left. So that meandering stream is now submerged under a pool. The trees and shrubs that like perhaps tag alder or willow that were there before get flooded and they eventually die. It kind of opens up the canopy. You might start to get some sedges or grasses growing in along the margins of these beaver ponds. They may persist like that for a number of years, depending on if the beaver are still there and able to maintain the dam. But as is often the case, they either get trapped or they move on, or for whatever reason, they're not there maintaining the dam, and the dams start to deteriorate. Because we tend to have, and that's kind of shown up in the image on the upper right and lower left, or upper right, up and lower right. Because many of these streams are lower gradient, particularly in northern Wisconsin, we don't always get very strong flood events that would dislodge these dams as they age and deteriorate. So you can often see these dams persisting for many decades after the beaver have abandoned these areas. And what happens when these dams start to deteriorate, they start becoming more permeable to flow, so the ponds tend to drain. What used to be a kind of wooded or shrubbed floodplain now may be a sedge meadow. But the stream, more importantly for trout, the streams themselves tend to now be wider and shallower. I'll show you a couple pictures of an actual stream kind of illustrating this. This is a picture I took last year on a stream called Elk Creek in southwest Wisconsin in the Driftless part of the state. And it just kind of shows a little meandering section of the stream. You can see the coarse gravel, cobble, rubble substrate, kind of little diversity in pool, riffle, and run habitat as it flows through here. Now, the next picture I'm going to show you is if you're standing on the stream and turn to your right, it'd be a kind of very long stone throw downstream where there had been a series of beaver dams. So this is a picture taken at the same time of the year. The dams that had been here had just been removed maybe a month or so prior to taking this picture. So those areas had drained. What was left behind is a somewhat wider stream. And we often see in these areas that have been flooded for a number of years, as this area had been, these banks, which had been previously been held together by vegetation. A lot of that vegetation dies, root systems may weaken, you get this slewing of the riparian material, the sediment, which kind of leads to that wider and shallower stream that you see here. So issues pertaining to beaver and trout are not new in Wisconsin. They've been around for a long time. If you look back in some of our old agency publications, you'll see articles like these, where I've highlighted how, the majority of trout fishermen feel that beaver impoundments eventually ruin trout streams. Or in recent years, beaver have thrived so mightily as to rouse the wrath of many fishermen since their ponds are factoring in the deterioration of some trout streams. Those attitudes were pervasive many years ago, and they're still pervasive today. But we are also experiencing quite the opposite. Has been over the last few years, a lot of growing interest among people who are not necessarily, or in many cases are not trout anglers, but they're very interested in beaver. And they kind of see beaver as the solution to all our habitat or climate-related issues. For anything related to wildlife or fish or what have you. So that's kind of the conflicting viewpoints that we're experiencing today. So kind of set the research stage for the research that I've been involved in. The image on the left is a picture showing the distribution of trout streams in Wisconsin. So we do have about 61,000 perennial stream kilometers of streams. Of those 61,000 stream kilometers in the state, about 21,000 kilometers are classified as trout streams, and about 2,700 individual streams. So it's roughly a third of our perennial streams are suitable for trout, streams in which we find trout. So they're not everywhere in the state, whereas beaver can be in any of these perennial streams. The image in the center is showing the distribution of streams for which the Wisconsin Department of Natural Resources contracts with the federal agency Wildlife Services to keep beaver and beaver dams off the streams. So those are the streams that Wildlife Services trappers are assigned to, and every year they survey those streams. If they find beaver, they'll trap them and remove them. If there are dams there, they'll remove the dams. The Wisconsin DNR contracts for that beaver control on about 2,400 kilometers and about 200 streams. You could probably add to that about a third of that, maybe another 800 kilometers that are supported by funds from the U.S. Forest Service, and those are shown in green on this map. So all told, it's about roughly 15% of the Coldwater trout streams in the state where we are controlling beaver. Now, it's not to say there's no control on other streams. That's largely up to the landowners, and we're very permissive in terms of what landowners can do if beaver are on a stream on their land. But again, you'll find some people that will want the beaver off, and others like having the beaver on their streams. But all these issues pertaining to trout and beaver have been outlined in our most recent management plans, the Wisconsin Beaver Management Plan in 2015, and then our trout management plan that came out in 2020. And it was a very involved process, particularly when we put together the beaver management plan. A lot of competing interests about beaver, and whether it's for trapping or wildlife interests, or in our case, fisheries. And as part of that plan, we did identify many of the gaps in the science, things that we think we understand about beaver and trout, but perhaps we don't have good data to support them. And that would be important to have if we are to, say, keep maintaining a control program because it's benefiting trout. So in that beaver management plan, we outlined a series of research needs. And the agency, through its prioritization process, kind of those research needs rode up the chain and eventually came to me in the form of the Beaver and Trout project that I'm going to talk to you today about. So I'll just start off by just clearly stating the objective of the study I'm working on, and that is the study will quantify the effects, both positive and negative, of beavers, beaver dams, and beaver dam removal on coldwater stream habitat and trout populations in the different ecoregions and beaver management zones across Wisconsin.
Can I ask you a question?
Sure.
Do you have any sort of historical baseline for what was the number of beavers estimated out there and what was the state of the trout streams back in the time when, let's say, beavers were intensively trapped for fur, and I assume the populations were much lower than they are today, and so on and so forth. So, because my question ultimately is, you showed us those pictures of what happens a few years after the dam deteriorates, but I get the sense that there have been beavers and trout on those streams for a very, very long time. So it'd be kind of interesting to know if we know anything about what would have been the state of these waters without too much human management.
Yeah, it's a good question, and it's not an easy one to answer in a short amount of time. I am going to touch on that question a bit throughout the talk, so I'll save parts of it for that. Some of the beaver long-term trend numbers have been outlined in the beaver management plan. So if you go to our DNR's website and just look up Wisconsin Beaver Management Plan, you can find that plan. You'll see some of the information in there. And then pertaining to trout and the trout plan. Certainly you go back far enough in time, beaver were abundant, trout were abundant. It has changed a lot over the years for various reasons. We essentially logged the entire state. We trapped beaver throughout the entire state. Beaver numbers really dwindled to the point where they were not really present in many places throughout Wisconsin at all. They did recover, and a large part of that is also because of the change in forests in the state. We have a lot of early successional forests in many areas that have many tree species that are amenable to beaver, like aspen or tag alder or willows or so forth. So those conditions change from decade to decade. And as far as trout, we did a pretty good job on removing trout for our streams as well. We had, besides all the logging that occurred up north and the logging drives through streams and the damage that did, we had a lot of livestock grazing throughout the state, very heavily grazed, that really did a lot of damage to our streams and wiped out trout. Whereas many streams, particularly in the southwestern part of the state, which are some of our best trout streams today, back 50 years ago, still in my lifetime, there were no wild trout there. So those things have recovered. So again, a lot's been going on over time. So what we see today in a landscape is a lot different than what was here 100, 200 or more years ago. But I'll get into that a little bit more as I keep talking. So I want to show you just a few pictures here to give you a sense of the different variety of stream types that we work in throughout the state. And I have these little colored dots that kind of relate where the picture is to which part of the state. If you look at the upper left corner, that's a Lake Superior tributary in northwestern Wisconsin. These are among our coldest streams in the state. They are a little bit higher gradient. There's a lot of clay in this area. When they do get precipitation events, they tend to run a little bit red, kind of color like in the image there. And one of the long-standing concerns about beaver dams in these streams is that having all that clay and fine sediment moving through the system would kind of get trapped in those dams and kind of mortar or cement them into place, making them somewhat permanent features on these streams. Moving to the picture on the upper right, with that green dot, that's in kind of north central Wisconsin. That's a very low gradient part of the state. These streams support mostly brook trout. Again, with that low gradient, when beaver build dams on very small streams, they create very large ponds. I forgot to mention on Lake Superior tributary, brook trout are native and found in there as well, but those streams are also important for lake-run salmonids today, like steelhead trout and coho salmon. Not native species, but important fisheries nonetheless. The image on the lower right is in northeastern Wisconsin. That's many streams there flow through cedar swamp type habitat. Again, somewhat lower gradient. When you do get rain events, water levels tend to rise slowly and fall very slowly. That picture is taken at bank full following a precipitation event. So a lot of water there, but not a raging stream. And then on the lower left, that's a stream in the driftless area of Wisconsin. That's an unglaciated portion of the state. So when the Wisconsin Glacier came through 10,000 or so years ago, that kind of portion carved out of the lower southwest part of the state remained free of glacial drift. We have a lot more topography in that area, that higher elevation land, higher gradient streams. These streams tend to be very flashy, prone to flash flooding. Again, brook trout were eliminated from many of these streams years ago by poor land use practices. We've been very successful in improving the water in these streams, both thermally and in other respects. But brown trout were reintroduced here prior to, instead of brook trout, I suppose. They become naturalized and are the predominant trout species in those streams. Just a quick few pictures, just illustrating some of our data collection. We do collect fish by backpack electrofishing. We'll do this with either one or two backpacks in our small streams. We are collecting data on all the fish that we catch, length, weight. We also tag fish for quantifying movement and survival. We'll use these visible implant tags, that are little color tags that go in the fins, or pit tags, electronic tags that are inserted into fish with an individual number. And with those tags, we can get capture histories for fish for further analyses. And we're also spending an equal amount of time collecting data on habitat features in our streams. This may involve stream width, depth, substrate composition, riparian vegetation, canopy cover. We're looking at riffle, pool, run sequences in streams, kind of that mesohabitat structure. Also monitoring water temperature and flow levels in our streams. And finally, the last piece of data that we're collecting pertains to beaver dams themselves. So we're measuring physical characteristics of beaver dams in terms of their height and water levels that they're holding back, and also marking dams with GPS coordinates and keeping track of the distribution of dams over time and how these dams change physically over time. So this is a map in the center here showing the distribution of the study sites that I'm working on around the state. The main experimental approach we've been taking for this project has been taking streams that have long been controlled for beaver activity. So they've been maintained under free-flowing conditions without allowing beaver dams to persist. We've removed the beaver control from those streams and have allowed beaver to recolonize. Those streams experimental streams are shown in red, and where you see a solid red circle, those are streams that we're seeing beaver activity on. Some streams beaver came on right away, others may have taken a year or two, but this is kind of where we're at now, about roughly 16 streams where we've allowed beaver to come back, and they have done so. We also attempted to go from the opposite direction, taking trout streams that have long had beaver dams on them to remove the beaver dams and document the changes that occur. We've so far only done one of those streams. That's that blue circle in Zone B. That's the Beaver Management Zone up in north central Wisconsin. Again, it's been difficult to find those streams. The issue is that there may be some trout streams that have long had beaver dams on, but we just did not have permission to remove the dams from those streams because they may be on private land, or they may be in state or federal natural areas where that removal is not allowed. So again, the primary approach we've been taking is streams that have been free of beaver, allowing beaver to recolonize, and looking at how that affects stream habitat and trout. And again, the figure on the upper left is showing the distribution of our beaver control program around the state. So our study sites closely mirror the distribution of where we're doing the control work. So I'm going to run through a series of slides just showing some of the examples of some of the observations we've been making and data we've been collecting. Again, this is an ongoing project. It's not final yet. I don't have a final report or final conclusions per se, but I do have observations that we've been making over the past few years that I want to share. The first few slides are going to show some of the kind of large-scale changes that have occurred by beaver dams being built on these small trout streams. This is LePage Creek in Florence County, northeastern Wisconsin. It's a very cold brook trout stream flowing through the state natural area. The red dots on these images show the location of the beaver dam. On the lower left is kind of a stream level view of the dam in question here. In the center is an aerial image of that dam, the dam at the lower part of the image, and then the stream is flowing from top to bottom in the image. So showing the extent of that pool that was created by that dam. So this pool extended upstream about 237 meters and covering an area of about 1.7 hectares. There is a lot of vegetation throughout that pool that has been dying back as it's remained flooded. It's difficult, perhaps difficult to see in the aerial image the extent of the water in the area, but all that area is flooded. Most of it is not wadable. It's perhaps parts of it around the edges are knee to waist deep, but it does get deep out there. And then if you look at the image on the right, that's kind of aerial image scaled back even more, just to kind of illustrate what the stream typically looks like without the beaver dam on it. So if you look down from the red dot where the beaver dam is, you can kind of see how narrow the stream typically is for LePage Creek. This is another one. This is in Sawyer County in northwestern Wisconsin. This is Benson Creek. Again, another low gradient stream, 0.35% gradient. Here, the image on the lower right shows the large dam in question. The image in the center, that red dot again shows that dam. There's a dot downstream that's orange. That's another dam downstream from there. Where that dam with the red dot on it was formed, it created a pool about 280 meters upstream, covering about 2 hectares. And on the image on the left, that 280 meters is from that red dot up to the yellow dot near the top of the image. Where that yellow dot is another beaver dam that is just barely submerged by the water from the downstream dam. So technically this pool is even extending further upstream beyond that. But if you look at that image on the left, you'll see that light green area to the left of the stream, and that's all a flooded sedge meadow. Prior to that dam going in, that sedge meadow was essentially dry. You can walk out in your sneakers or whatever all the way up to the edge of the stream and not get wet, except for perhaps a few little spring channels that flow in. But since the dam was put in, the stream has been flooded, that sedge meadow area has been about knee to waist deep, again, flooded with water, and that accounts for that 2+ hectares. And then one more, this is on the Ounce River, also in northwestern Wisconsin. This is a little bit bigger water, also a lower gradient area. The dam on the lower right went in just downstream of the 2-lane state highway crossing the river. And the image in the center shows, again, that red dot just on the left side of the highway. And that created a pool extending about 845 meters upstream, covering about 8.7 hectares. Again, in that aerial image, you can see well the outline of the stream itself. All the vegetation on either side of the stream, again, became flooded and, again, kind of knee deep, waist deep, depending where you're at, accounting for that 8.7 hectares. The yellow dot on the image on the upper right, and which is down near the lower end of the image in the center, is a beaver dam that was upstream from the beaver dam with the red dot. That lower dam, flooded water backed up and submerged that upstream dam. And there were actually a series of those dams in addition to that when that became flooded by the lower dam. The orange dot near the top of that image in the center is the next upstream dam that is not flooded by water from the downstream dam. So that's the 845 meters upstream. So these just kind of illustrating that these individual beaver dams being built on these trout streams are creating pretty significant changes in the physical structure of these streams. I'm going to move on a bit to some kind of covering the mesohabitat structure in our streams, or with, as trout anglers, you may refer to as the pools, riffles, or runs. Just some quick definitions, starting on the left, pools. This is the deeper water, little or no surface turbulence. Water velocity tends to be slow. Riffles in the center here, kind of the opposite, shallow depths, surface turbulence, faster water velocity. And then on the right, the runs. This is kind of in between, average depths, perhaps little or no surface turbulence. The water velocity could be a little slow, could be a little fast. So we've been keeping track of this type of habitat structure across our habitat survey sites, which extend over a couple hundred meters and then over longer multiple kilometer surveys of these streams. So the way I'm displaying this data in the bar graph figure here, I've color-coded pools to be red, riffles to be blue, and runs to be yellow. And so if you start at the bottom of these bars, where we may start a survey, in two cases, sites 1 and 3, those X's indicate a beaver dam was there, and the water here is flowing from the top of the page to the bottom. Putting those beaver dams in these streams created pools, essentially. In the left, site 1, that's the image on the upper right, kind of the aerial image showing that dam. You can see the somewhat narrow braided channel of the stream downstream of the beaver dam, but above that, the big pool that was created. The area is not directly affected by beaver dams in the stream. Site 2, which is pictured on the lower right, and another site further downstream, site 4. In this higher gradient driftless area stream, relatively high gradient for Wisconsin, we do tend to see quite a bit of variety in this pool riffle run sequence, where most of the habitat seems to be riffles and perhaps runs. Pools tend to be somewhat limited. But again, when beaver dams are built on these streams, it completely flips the script, so to say, and changes these areas into largely pool habitat. This is similar data for a somewhat lower gradient stream in northeast Wisconsin, in Holmes Creek and Marinette County. Here, the two bars on the left are, again, those X's indicate different beaver dams that were encountered, essentially creating, for the extent of the surveys that we did, just simply pool habitat. Whereas other sites on the stream, site 3B, which is downstream of the beaver dam, and site 4, which is not anywhere near any beaver dams, the stream tends to be largely run habitat, interspersed with small pools here and there. We didn't capture any riffle habitat in these smaller survey areas. It's not to say riffle habitat doesn't occur in these streams, but it is kind of rare. Again, kind of, in a sense, highlighting the importance of that type of habitat, recognizing its importance for spawning trout. That said, brook trout tend to do well in these streams. Although they don't have a lot of riffles, they tend to be sandy streams. Brook trout, as opposed to brown trout, do successfully spawn in those types of streams. I'm going to switch here. Color code is changing a bit to kind of narrow in a little bit further in terms of habitat and show you substrate characteristics of the streams. So this is data for the same stream, Holmes Creek in Marinette County, that sandy stream I was talking about. And here the color coding, which I show on the right here, I use these warmer colors to indicate finer substrates like silt, sand, or detritus, or clay. And then the coarser substrates, gravel, rubble cobble, boulder bedrock, are those cooler colors. So in this lower gradient stream up in northeast Wisconsin, it tends to be a sandy stream. You see a lot of that yellow on these figures. You don't see a lot of the coarser substrates. It does occur, but again, not in very many places. But when you do get beaver dams on these lower gradient streams, as shown by the X's on the two bar graphs to the left, you start to see more of that finer substrate settling out and covering the stream beds in these streams. But these substrate characteristics become a little bit more starkly different when you look at other types of streams around the state. So again, this is in a more higher gradient area, 1.2% gradient stream in southwest Wisconsin. This is West Branch Tainter Creek. The bar graphs here coincide with the aerial image to the left. So there's a beaver dam in the middle of that image, which corresponds to the 0 on the y-axis of the figure here. So the stream is flowing from the top of the image to the bottom. And where that dam was built in the stream, it slowed the water velocity. It started capturing a lot of silt falling out of the water column and kind of burying the substrate. And that shows up as the orange in this bar graph. Whereas if you look downstream in the beaver dam, where you don't have that water being slowed by the beaver dam and pooling up, you do tend to see more of a variety of those coarser substrates like rubble, cobble, and gravel, which we know are very important for many of our aquatic insects and trout reproduction in these streams. I'm going to move on here to back to Holmes Creek, a different section of that stream, and talk a bit about not just the habitat changes from the beaver activity, but also what it's did to thermal conditions in the stream and to the fish community. So these images are taken up in the headwaters of Holmes Creek. In the upper left is two of my field crew members walking underneath the railroad overpass. So the stream kind of intersects with the railroad and flows underneath it. If you look at the image on the right, that's upstream of that railroad overpass. It's a narrow stream that kind of flows through a meadow and woodland type complex. You can almost barely make out the head of one of my crew members walking through the stream there. On the lower left is an image of the stream downstream of that railroad overpass, again, kind of flowing through cedar swamp habitat. One of our crew members is electrofishing there, and image on the right is one of the brook trout that was captured from this stream. So this was one of our study streams that we removed beaver control on and allowed beaver to recolonize, and they did. And they formed a number of beaver dams just downstream of that railroad overpass. The image on the upper left is a dam, that kind of a half-moon shaped dam that was built right at the railroad overpass. So you can kind of see to the left that little concrete structure above which is the railroad. That's the underpass that my crew members were walking under or wading under just a year before. Now it's been backed up by water from the beaver dam. The image below that is looking at that overpass from the upstream side. So that water level is kind of right at that top of that tunnel area where the railroad goes over. And then the image on the right is looking upstream from there, looking at the area that got flooded by that beaver dam. And this is showing some of that vegetation already dying back. Now I'm going to zoom back out to an aerial image. So this is that same area. That red dot is showing that beaver dam in question at the downstream side of the railroad overpass. And then to the left of the railroad berm and the overpass is the pond that was created by that beaver dam, by that one beaver dam. So this created a pool reaching about 418 meters upstream, covering about 3.5 hectares of water. And you can see a lot of that vegetation at the time this image was taken has now died. So this gets back to that question about beaver and brook trout coexisting in the Wisconsin landscape. They have in the past, but they haven't in situations like this in the past. So this is a situation where, the landscape use has changed. We put in a railroad here, and beaver essentially took advantage of that to create a pool that they otherwise perhaps would not have been able to have created had that railroad berm not been there. So again, an example of how things are a little bit different today than they perhaps were in the past. So these are a couple figures showing thermal conditions in the stream. And I've color-coded this based on kind of work that some of my colleagues have done in the past about thermal conditions in streams and what those thermal conditions, how those thermal conditions relate to fish communities that you'll see. So we can so I've color-coded these bars on the graphs, and you can see the water temperature on the y-axis. On the left figure, the July to August mean temperature, and then the right figure, the July mean. So essentially, we put a water temperature data logger in a stream that records water temperature every hour, and it's just taken the mean of those hourly measurements over a 3-month period during the summer or the 1-month July period during the summer. And our streams that thermally fall into what we call the cold category are our trout streams. They support trout. And if you see any kind of cool or warm water fish species, it's largely just incidental. They tend to not do well there. Our cold transition streams are also our trout streams. Trout do very well in those streams as well. But you will start to see more cool and warm water fish species occurring on occasion. Then as they further warm, it becomes what we call a warm transition stream. You may still see trout in those streams, but typically not a lot. And you will tend to see more cool water and warm water fish species. And then our warm water streams, you no longer see trout, and you're now only seeing these warm and cool water fish species. And I'll show you some examples of those fish species in a minute. So what we saw in terms of water temperature on Holmes Creek, when we first started measuring in 2019, there were no beaver on this section of the stream. Beaver started building a dam sometime between 2019, late 2019, early 2020. And as that pool filled up upstream of that railroad crossing, and then the vegetation died back, over subsequent years, that water temperature during summer started to warm more and more, whereas such that the thermal condition in these streams were now turning into cold transition by 2020, by 2021, 2022, turning into warm transition to warm streams. And then more recently in 2023, these were essentially, or at least this section of Holmes Creek was essentially a warm water stream where we no longer found trout. So again, species that we like to see or typically see in our cold water streams are species that are intolerant, what we say are intolerant to degraded stream conditions. So this is our brook trout or mottled sculpin, perhaps these non-parasitic brook lamprey. And when our stream conditions do start to degrade, or maybe they become thermally less suitable for trout, more suitable for cool water or warm water species, we start to pick up a lot of these species: western black-nosed dace, central mud minnow, brook stickleback, white sucker, creek chub, or green sunfish. And there are many others as well, but perhaps less common. So here I put together.
Sorry. Just a quick clarification. Where were these water, I might have missed it, where were the measurements for temperature done? In the pool, downstream of the pool, or somewhere else further down on the stream?
These temperatures here?
Yeah.
Yeah, this was a data logger that was about maybe 100 meters downstream from that big pool created by the railroad.
Oh, okay. Thank you.
Yep. So here I put together a schematic just to kind of illustrate the change in fish community structure as it related to the change in thermal condition and beaver activity on Holmes Creek. So if you start at the left, in 2019, you have that blue stream depicted there with the railroad crossing up top and two road crossings below it. Fish surveys at that time, we were finding trout pretty much everywhere we looked. Some mottled sculpin. We did find a couple of mud minnows, but nothing else. By September of 2020, the next figure over, a number of beaver dams had been built, including the one up by the railroad crossing. We started seeing somewhat warmer temperatures, what we would call a cold transition stream. We started picking up a lot more different fish species. I highlighted that we were still seeing brook trout, but we're also, and mottled sculpin, but we're also picking up these cool and warm water fish species like black-nosed dace, brassy minnow, brook stickleback, central mud minnow, creek chub, pearl dace, white sucker, probably a few others as well. One thing that was interesting in terms of number of brook trout in relation to beaver dams, in September 2020, most of the brook trout we saw were downstream of the lower beaver dam depicted on this image. And I wasn't going to get into it too much in this presentation, but what we found from work a PhD student that was working with me did on trout movement in streams in this part of the state. These streams do get very cold in the winter, and they freeze over and are not quite as suitable for overwintering a trout. And we find that there's a lot of seasonal movement of trout from the headwaters to deeper downstream areas for overwintering. And then in the summer, that movement's reversed and these fish start to redistribute back upstream. So if that was the case in 2020, moving back upstream, they may have started to encounter these beaver dams, and that could potentially be an obstruction to movement, or why we would have seen more of them downstream of that lower beaver dam than upstream. By the middle figure here, June of 2021, a couple dams were lost, but not the one up by the railroad area. We were no longer seeing any brook trout upstream in the beaver dams. Still seeing a lot of cool and warm water fish species. We were still picking up some brook trout, but they were all downstream of the Beaver Dam. By July of 2022, the fourth figure over, again, still in this context, a warm transition type stream. Many of those beaver dams were rebuilt. We were no longer seeing trout up there. Picked up one mottled sculpin, but mostly non-coldwater fish species. And then by September 2023, this past year, thermally, the stream was now considered a warm water stream. No longer seeing trout anywhere, no longer seeing mottled sculpin, just these warm water, cool water fish species. So this kind of illustrates how thermal conditions can change in the stream in relation to beaver activity, and then in turn changes to the broader fish community, including trout. This is not to say that trout are absent from everywhere in Holmes Creek, but certainly in this upper headwater portion of the stream. In many of our streams, you do get spring input as the stream flows down, so you do have colder areas further downstream. So brook trout were persisting at other areas in the stream. I'll leave you with one more image of this stream. This was taken last late November, I think. And again, that red dot showing where that dam used to be downstream of the railroad bridge. So it turns out this dam blew out, and we pinned it down to November 15th is when that occurred. And the whole pond completely drained. And then what you're seeing here is what it looks like now that it's drained and there was a little snow cover on it. We are going back to the stream for the first time this year, next week. I am kind of hoping that beaver have not rebuilt on here. I would like to see if perhaps thermal conditions will change this year such that it would be more amenable to trout again now that we don't have that beaver pond there. But we'll get an idea of what we're up against this year when we visit the stream next week. One more piece of data I want to share with you on water temperature data. This is for Elk Creek in southwest Wisconsin. It's one of the streams that I've worked on almost since I started with the DNR, and I have paired temperature data that proved useful in relation to beaver activity on this stream. I want to show you that data. Here's an image of on the left, the beaver dam on Elk Creek. And on the right, you're looking at just kind of a wall of willow that are along the stream. And this is essentially candy for beaver. And it's one of the reasons why beaver have been so active on many of our streams in this part of the state, just because of this proliferation of willow. So here on the figure on the bottom is water temperature data, but first I'll draw your attention to the map up top. So that's an aerial image of Elk Creek. The water is flowing here from the right to the left. Those red and yellow diamonds indicate, as of 2020, the presence of beaver dams on Elk Creek. So you can see this big cluster of beaver dams in the center of the image. And those fall, there's about 14 of them, and they fall between two long-term monitoring sites I have for water temperature. So to the right, you'll see a letter U in a green square, and that corresponds to the green squares in the figure below. That's our upstream water temperature data. And then all the way to the left of the upper aerial image is a letter D in a yellow box, and that corresponds to the yellow symbol in the figure below. That's our downstream water temperature data. So I have this paired data going back to 2011, and prior to beaver dams starting to be built in 2017, the difference in July mean temperature that I'm showing here between those two sites was remarkably consistent, about 2 degrees Celsius cooler on average downstream than upstream. And although from year to year it varied, July mean temperature varied, that difference between sites remained relatively consistent. It's not unusual that these streams get colder as they flow downstream because we do have a lot of spring input at various locations along these streams. Again, beaver dams started being built in 2017. That was just prior to the start of this project, but for whatever reason, beaver control, though it was supposed to occur in the stream, it didn't. I think there were some changes in management personnel, the fish biologists in the area, and that might be why it fell through the cracks. But when I knew this project was coming up and that I had long-term data on the stream, I was quickly able to keep that beaver control off. And after 2017, beaver activity just took off. And by 2020, this is what we saw on the stream. So after that time period, as beaver activity started increasing, we started seeing this kind of convergence of July mean temperature at those sites, such that by 2020, there was no significant difference at all between upstream and downstream water temperature. That yellow symbol is on top of the green symbol. So there's data for both sites. It's just about the same temperature. And then from 2021 to 2022, it started to diverge such that it was now warmer downstream than it had been upstream. There was a change in the spring of 2023. I think a landowner in that area had ultimately decided to remove those dams. Again, it's an area that's not, that particular area is not public land. The area to the right on the image above is, and we were able to keep those dams there. There's fishing easements to allow anglers down there, but the landowner was able to take the dams off. And then what we've seen in 2023, starting to see that reversion of water temperature such that it's now starting to be a bit colder again downstream and upstream. So as of this spring, there are still no dams in that center portion of this figure up top. So we'll see if that persists during our summer water temperature monitoring, and if those temperatures continue to get cooler downstream now that those dams are no longer there. And the last stream I want to share data with is the East Fork of the Flag River in Bayfield County. This is one of our Lake Superior tributaries. There are native brook trout in the stream, but for the most part, from a fisheries management perspective, these streams are very important for lake-run salmonids that spawn in them. And this includes steelhead trout and coho salmon. Now, as it turned out, this was a stream we were working on there in that area that was technically a control stream. They didn't want to take beaver control off it. But in September of 2022, when we were doing surveys there, we encountered these beaver dams, a series of 3 beaver dams. This is one of them that had just been built that hadn't been there the year prior. This was the first stream in that part of the state where we started getting beaver activity that we'd been actually collecting data on. So we were able to convince the management to allow these dams to stay there. So they were there for the fall spawning run of 2022, when steelhead trout and coho salmon would be running up this river to spawn. I guess I'll step back one second. We were wondering if perhaps some of these lake-run salmonids might be able to make the leap over this dam. This water was kind of pouring over through this little notched area into a deep plunge pool on the downstream side. So it seemed conceivable that a motivated salmonid might be able to make that leap and get over. We did put up a trail camera that we had to kind of get a sense if we can capture any images of that. Got some neat wildlife photos, but no fish photos. In retrospect, it was probably not the right technology for capturing the motion of fish jumping over a dam. We might try that again in the future, but as far as whether or not fish made it over, we had other ways to check on that. Before I get to that, a couple aerial images of East Fork Flag River. So on the left is, again, that fall of 2022. These red dots showing that series of 3 dams. Here, the water flowing from the bottom of the image to the top. There was a breach of these dams in the spring snow melt. We had a very heavy snow winter in 2022, 2023. And when that melt occurred, many of these dams were breached, shown in the image on the right, and then the inset image captured on our trail camera. So while the dams were there to block the fall migration of coho salmon and steelhead trout, there was a spring migration of steelhead trout, which conceivably could have gotten past these breached dams. And our fish surveys suggest that they did. So we went in the following autumn, so this would have been last September 2023, and we did our fish surveys. And if the lake-run salmonids successfully spawned, we would find young-of-year steelhead and young-of-year coho salmon. We found these young-of-year steelhead and young-of-year coho salmon all the way up to the first dam. When we went in above the dams, we had to go up a little bit further where we can wade, and then did some extensive surveying upstream of the dams. We did not find any coho salmon, but we did find steelhead trout. So we can't say for sure whether or not the steelhead got over these dams in the fall, but given that these dams were breached during the spring steelhead run, that's likely the time when they would have made it past those dams. But the dams did prove to be an obstruction to movement for coho salmon. So these dams were rebuilt following that spring runoff. In fact, they're a little bit more extensive now. This is an image that was taken about a month ago, showing a portion of the stream. I didn't put any dot on here to show the Beaver Dam in question, but it's, I don't know if I have a cursor that you can see, but it's kind of in the lower center of this image, one of those dams. And if you look to the right of that dam, you'll see what the stream naturally looks like in terms of how narrow and shallow it is. And then to the left of the Beaver Dam, just showing the extensive pool that was created. And it's kind of unusual. We don't typically see this in many of other streams with beaver dams, but the water is very cloudy. And that might be due to that kind of clay and sandy sediment that we have moving through this system. Again, having that higher gradient stream and getting the substrate being washed into these beaver ponds, and it might just be remaining suspended there. So these dams were up this past fall, again, to potentially block the fall spawning migration of coho salmon and steelhead trout. We had a very low snow winter this winter. Those dams persisted through the winter, so they should be there to have been potentially blocked the spring run of steelhead trout as well. So we'll see this coming September when we return to the stream, whether or not any of those salmons were able to get past these dams to spawn. So I'll just finish up with a few preliminary observations. Again, beaver dams and streams can lead to more larger trout. We typically see this in the size structure in our fish surveys. In many of our smaller streams, you'll see brook trout up to a certain size, but when you get a new beaver dam in there and conditions are favorable for growth, we will start to see some larger trout. And this is also proven to be the case for brown trout. And so that's, in a sense, how brook trout may have a positive response to beaver dams. There have been some streams where we have both brook trout and brown trout, where you start to see a little bump up in brook trout where beaver dams are, but we're talking very small, from maybe brook trout were 1% of the population bumping up to maybe 5% in the area where the beaver dam was. So certainly not going to flip a stream from brown trout to brook trout. We've done some work documenting the importance of seasonal trout movement in northeastern Wisconsin. I didn't get into any of the specific data on that, but it's very important in terms of how important connectivity is in our northern streams because of the thermal conditions during winter and the need of these fish to move among different types of seasonal habitat. So we're very interested, of course, in to what extent beaver dams may be affecting those seasonal movements of brook trout. We've had evidence of beaver dams blocking spawning movement of Lake Superior salmonids, in particular coho salmon, and it appears to be steelhead trout as well, but we'll know for sure this coming year. I've shown you images of these major changes in physical stream habitat, again with these low gradient nature of our streams, these small dams on small streams creating just these very large pools. We've had some evidence for warming of water temperatures. In the example of Holmes Creek, it actually warmed to the point where it was no longer considered a trout stream, at least that section of the stream. Other streams like Elk Creek, evidence of warming, though not to the extent that it changed the thermal suitability for trout. So again, that warming effect is likely very site-specific or stream-specific. And then again, disruption to the trout population dynamics and fish community dynamics, particularly in terms of seeing these non-cold water fish species just popping up in greater abundance in beaver dam streams. So I'll finish with a few acknowledgments. For this project, we've done a lot of travel over the past 4 years around the entire state, pretty much from April through November. And big thanks to my crew, Nick Hoffman, Mariana Mateus, Spencer Vandenbloemen, Ben Breaker, Dr. Emma Lundberg, and Kat Ahrens. Mariana, Ben, and Emma have moved on to other opportunities. Nick and Spencer are still working with me, and Kat came on this year. I do want to make a note of that fish that Kat's holding to the right of this image. That's a brown trout that was caught in Elk Creek. This is a further downstream from where I showed you the temperature data on Elk Creek. There was a very large beaver dam that was on an easement area, and I think a landowner come in and removed a dam once. So we thought, if that's going to happen again, if the dam gets rebuilt, perhaps we'll go in and remove the dam so we can get in and do a fish survey. So we came back this spring to do that. The dam in question was no longer holding back water. It deteriorated, but a new dam was built about 100 meters downstream. So that dam was not there in October. It was there in April, so less than 6 months. We notched that dam and drained it and did a survey there, and that trout that she's holding is typical of what we found in that pool. We've not seen trout of this condition anywhere else in Elk Creek. They were just gorging on cranefly larvae, turned out, and had responded very quickly in terms of growth, just in that beaver dam being there a short period of time. So thanks to our funding from Sportfish Restoration and Wildlife Restoration. And with that, I'm happy to answer any questions you may have.
I have one.
Okay.
All the minnows, where did they come from? They didn't show up in your earlier surveys, and yet as the water increased in temperature, suddenly these minnows appeared. Where did they come from?
So I think what happens is we have a lot of thermal variability in some of these streams, particularly up in headwaters. So it's not like mountain streams you may see out in the Intermountain West, where they're very cold coming out of the mountains and tend to warm up as they go down. In many of our Wisconsin streams, they start out relatively warm, and then you get spring input, and they start to cool and become thermally suitable for trout. So I'll use Elk Creek as an example. So it's a phenomenal brown trout stream now, very cold and produces a wonderful fishery. If you get much further up in the watershed, it turns warm, and you no longer have trout, and you have all these warm water fish species up there. So I think does happen is over time, those warm and cool water fish species are not stationary. They do move. Maybe they reproduce. I think there's a lot of drift at night. We've actually documented some of that in a stream in northeastern Wisconsin. We were putting out fyke nets trying to capture post-spawning brook trout. They were kind of sparse to catch by electrofishing, and we just kind of thought we'd give it a try to see if we can capture any large downscale movement. And we did hit them in 1 out of 6 nets, but in all our nets, we were capturing all these non-games fish species at night. So we're not seeing them in our daytime electrofishing surveys, but at night, they were apparently drifting through. So that may be what's happening. They're drifting at certain times, and if the conditions are suitable, maybe they're stopping, and that's where we're seeing them now in our beaver dammed areas. Perhaps if they're not, they're keep moving down or being eaten by trout.
Okay. Thank you.
Yep.
Looking at the pictures, it seems like it's a very wet area. So those of us living out west here, we're kind of very sensitive to not just warm temperatures, but low flows are a huge issue. And with the snow dwindling and the glaciers melting away, it's going to become probably an even bigger issue. Is there anything like, I have no idea what Wisconsin's like. Is it fairly stable in terms of water flows? Is that a concern for you at all, or that's not an issue at all?
You're right. It is very different in Wisconsin compared to the West. We are a very wet area. We're generally not short of water. That said, we do have our droughts. This happened to be a very dry winter. We didn't get much of a snowpack this winter up north, and many of our major rivers are running very low. But again, don't deal nearly with the type of water issues that you may be dealing with. So that's not typically a concern here. And that's one of the reasons. Oh, go ahead.
Matt, I have a question. I noticed the gradient on most of the areas you're working is basically, 0.3 to 0.2, very low gradient stuff. What would you, and then one of the problems that where we live in the eastern slopes here, we have a diversity of gradients. For example, Elk Creek out here, west here, it's relatively low. Some of the areas in Upper Prairie Creek are like that. Once it gets further down, change. What would you think would be the maximum flow that you would look at in order not to deal with beaver management? Like in terms of gradient, would it be like 1 or 2 per 100 or?
Probably be much higher than that. There is some data out there in the literature, not a lot, but some. The gradients that I've encountered on these streams is kind of that sweet spot for beaver. It's very ideal for them.
Yeah.
They do very well there. They will on occasion build in higher gradient areas, but the dams are less likely to persist in those areas.
Mhm.
I guess that's the major difference.
The second question I've got is that the food resource, you mentioned deciduous. Like around here, poppers are lollipops to beaver.
Mhm.
Is that the same situation down there?
Yep. Yeah, poplars are very good for them as well.
What about willow and stuff like that? I noticed you had some small in the dam structure there, a lot of 2-inch material.
Mhm.
Is that typical?
It is. Basically anything they can get their teeth on and drag to a stream, they'll use. We've seen them build dams out of corn stalks, if that's what's there. They do need. They're not going to feed on that. They do need the willow or the poplar or the aspen. Willow are a big problem for us in terms of. Well, I guess it depends on your perspective, but if you have a lot of willow, you can have a lot of beaver. And in fact, if I can get back to an image here. Might be difficult to see in this image here, but this is the East Fork of Flag River, and it kind of flows through a very steep valley. Kind of most of the forest around it is very mature, and you don't see a lot of willow. But I don't know if you can see it in this image here, but where the beaver built the dam on this stream was basically the only place I saw willow. So they are keying into those woody species.
Well, see, we seem to have an area in the province here, and it's east to west. It's a relatively narrow area where the deciduous lands exist. And for example, west of us, it pretty well runs out about 25 miles west of us, where you switch over from deciduous to conifers. And then, of course, the willows and all that kind of stuff extend all the way out, good Lord, all the way to you. If I've been down to Manitoba, and there's all kinds of willows and poplars down there, and lots of beavers. But I think there's a narrow area in this area that benefit from it. I just was curious. So, yeah. The last question, next, I'm sure I have more. How much money do you contribute from the sportsmen to this activity?
To the beaver control program?
Yeah.
So our beaver control program, I'm in the fish research group that comes out of our fish management group. I want to say it's an allocation of maybe the $300,000 a year range. And so that largely comes out of either license fees or sport fish restoration funds. I'm not 100% sure, but out of the general funding that we have for fish management. And it's largely perceived as a very cost-effective program for what we get out of it.
Yeah. And so we have a program in Alberta called the Buck Wildlife Fund, or whatever the hell it's run by ACA now. But yeah, and it's primarily raised from sportsmen's funds. And but we don't spend very much money on beaver management, other than the major cities. We spend a lot of money there because they don't want the shrubs cut down. You know what I mean?
Yeah.
Skylar, we got a question in the back here. Just go ahead.
Yeah, when you're dealing with the beaver management, is there a specific spacing you're working with, or are you just trying to clear the whole stream flow? Is there a set spacing you're working with between dams that you're trying to keep clear to allow a certain flow, or are you trying to just keep the whole stream clear within this set range?
Yeah, if it's a stream that we're controlling beaver on, we're trying to keep the entire stream clear. That said, it depends on where we have access to the stream. So if we have extensive access to the stream because it's on public land or it's on easement or we have landowner cooperation, it's essentially keeping beaver off everywhere. And the reason that Wildlife Services, the people who do the beaver control will tell you, is if you leave beaver anywhere, they'll come right back. And I'll give you one example. There was a stream we suggested for removing a beaver dam to see if we can return conditions, but The public portion of land where the beaver dam occurred was very short. And they were concerned that if they removed beaver from that portion, there was so much of the stream they did not have access to control, that beaver would just come right back in and it would just be a fruitless effort. So it's kind of an all or nothing thing.
Okay.
Question in the room. Dean, go ahead, and then we'll have Mike.
Thank you, Matt. I'm sorry if I missed it, but how do you make a decision on whether you're going to do beaver management on a stream or not? There sounds like there's many different components to that.
Yeah, no, I didn't talk about that. That's largely a fish management decision, and a lot of it goes to the discretion of the fish manager who works in the county. Although they do, tend to follow guidelines and that there needs to be a perceived benefit to trout in doing so, or detriment to trout if you were to leave them in there. One of the main factors that also goes into this is kind of related to funding too. In Wisconsin, when you're a trout angler, you buy a fishing license. If you fish for trout, you also buy a trout stamp. And that trout stamp money is dedicated to habitat work, which in Wisconsin tends to be, kind of physical in-stream habitat work where we're going in with heavy equipment and putting in structures in the stream or restoring the stream channel or things of that nature. And it's very expensive work on a, per mile or per kilometer basis. And when we do that work, we want to realize the benefit of it. So if there's a threat to that work by beaver building a dam and then completely flooding and submerging it, that would be a case where beaver control would be warranted, and to be able to keep that habitat work functioning.
Question from Mike. Go ahead.
Okay, thank you. Thanks a lot, Matt, for a great presentation. I really enjoyed it. A couple of years ago, I went through and did a literature review, peer-reviewed literature, looking at the impacts of beaver activity on trout populations, including a lot of great work out of Wisconsin. So thanks for that. But I was kind of struck by an observation that it felt like a lot of the earlier literature, certainly in the 50s, but up into maybe the 90s, it really focused on the negative impacts, whereas kind of a lot of the more recent literature was highlighting a lot of the more positive impacts. Almost it's as if the pendulum had swung from one extreme to the other. I'm curious, would you agree with that assessment? And what do you think is behind that, if indeed it is true?
I guess yes and no. I think I certainly see what you're seeing, and my perception is that to a large extent, the positives that you're seeing are coming out of research done in different geographic areas, particularly out of the Northwest and not out of the upper Midwest. I don't know if that aligns with what you're seeing.
Yeah, I would say that definitely. One thing is there seems to be a lot of questioning the potential for a beaver dam to be a barrier to fish movement, which I just find baffling, just kind of based on even anecdote. It just seems so obvious to me, and you were showing great information as well on that. Now, certainly, it's very case specific, but nevertheless, it just seemed to be a really deep reevaluation of the potential of beaver to impact migrating fish. Yeah, but it makes sense. The geography, the context is everything in these conversations, right?
Right. Are you saying it seems obvious that they would be a barrier to movement?
To me, yeah. But again, perhaps those are just the streams that I'm looking at in those situations.
Yeah, I certainly agree with that perception. I've seen over the past few years so many beaver dams on so many different streams, and I look at these and I have a hard time conceiving even how water gets through them, let alone fish. Certainly there are some cases where you get an area stream flooded and perhaps it backs up enough that water starts flowing a side channel around a dam. And, maybe a fish that's motivated could get through there depending on the size of the fish. But like you said, overall, it would seem like, if you have a large population of fish that does a large seasonal movement up and down these rivers, having an obstruction like this, logically it would be some kind of impediment to them.
Yeah. Thanks again for the presentation.
Thank you.
One last question, Michael?
When you're talking about beaver control, is this lethal control? Are you killing the beavers? Or are you just moving them someplace else?
It's lethal control.
So
The
weapon and shooting.
issue in Wisconsin is there's nobody that wants them if you're removing them. There's just so many beaver in so many places around state. It's, unlike what you're seeing in other parts of the country, where it's just the opposite, where they don't have as many beaver as they want.
Okay, thank you.
And just to show again how, that lethal control is not decimating beaver. As soon as we stopped lethally controlling them on these study streams, within a year or two, beaver are back.
Okay, thanks very much, Matt. That was a very informative session, and there's a lot of folks in here that are nodding their heads and very appreciative of the information that you passed along to us tonight. Once again, thank you very much. Especially it's 10 o'clock your time now, so we'll be conscientious of your time as well. Thank you very much.
You're welcome. I'm more of a night person, so this is fine with me.